This is practice question video for circle theorems, and if you have not gone through circle theorem step-by-step revision questions, then better to go through those part 1, part 2, part 3. And if you have gone through that one, then this is the video in sequence with that. So we'll be dealing with practice question related to the circle theorem. The part 1, part 2, part 3 which I'm mentioning are step-by-step videos covering these rules, and I will not be taking these rules individually in this video. So go through those 3 parts as well before going through this one. Now we will start with these rules. These are the rules, 10 rules which we are talking about, and these 10 rules are for circle theorem, and we will be choosing a circle theorem tricky question, difficult question, and we will be checking which rules need to be applied for that. We have chosen this question for practice. If we see, this is the circle and this is a straight line touching this circle, so this is the tangent line to this circle, and this is angle K which we need to find, and this angle L is also required, and this angle is provided which is 23. So we can take this one as origin. This is like origin. This point we can take like A, B, C, D, E, F and G. So we have labeled this drawing for our understanding purposes. A, B, C is tangent, and we know tangent and diameter or radius. We have this rule, so we can go through that rule. So this rule is related to the tangent, and it is saying a tangent to a circle makes a right angle with the radius at that point. So this is the rule which we will be utilizing. Now this angle, by that rule, this angle starting from this point to this point is 90 degrees. So this is 90 degree angle, and if we see, this triangle is not in semicircle, so we can't take that rule. So this is 90 degree. It means K plus 23 is 90 degree. So we can write here K plus 23 is degree is equal to 90 degrees. This implies K is equal to 90 degrees minus 23. So 90 minus 23 will be equal to 67 degrees. So this value will be equal to 67. So K is 67 degrees, which we have found. We are looking for this angle which is L. That one we will be checking. First we can apply another rule. You can see this is K which is 67, and this is the segment which is BD, and this is triangle, and we have another rule which is relating to this K angle and the angle in another segment. So this angle, so angle DFB and angle ABD are related to each other. This angle, if I'll draw arrow for your understanding, this angle and this angle are related by a rule, and that rule we can discuss that rule. That rule is over here, rule number 9. This one, this is saying alternate segment theorem, the angle between a tangent and a chord. So this is tangent and this is chord. So angle between tangent and chord is B. is equal to the angle subtended from the ends of the chord in the alternate segment. So this is alternate segment angle B. So this angle will be equal to this angle B. So by this alternate segment theorem, we can write this B is equal to B. So in this case, these are the two angles which we have related. So it means K is equal to this angle. This K is 67, so this angle will also be 67 degrees. We reached up to this angle which is DFB, which is 67. Now we can find this L. Our target is basically to find L, and we know DFG is a straight line and angle at a straight line is 180 degree. So we can write angle L will be equal to 180 degree minus 67 degrees, and 180 minus 67 is equal to 113. So we can mention here 113 degrees. So this will be our answer, 113 degrees. And the two rules which we have utilized, we will have to mention in the justification part, and those two rules which we will be mentioning are: number one, this rule, which is tangent to a circle makes a right angle with the radius at that point. This will be the justification. And second justification will be this one: the angle between a tangent to a chord is equal to the angle subtended from ends of the chord in alternate segment. This is the second practice question which we have selected. So this is a circle, and this F and G we have to find, and these are two indications that these are equal. First of all, we can label it for our understanding. This is origin, so or center of the circle. So we can say A and B and C, D and F. So these are the points which we have labeled. Now we can, if we see this question as a whole, so we can see that this is the diameter, and diameter is intersecting this chord which is AC. So we know we are having a rule which is relating to diameter and a chord. So if we go through that rule, this is the rule which is relating to the diameter and the chord. So this is saying a diameter bisects a chord at right angles. So this is the information which it is providing, that if diameter is bisecting a chord, it will be making 90 degree angles. So if we apply this rule, this will be, by that rule, this angle is 90 degree angle. So this information we are copying over here. This is 90 degree. If this is 90 degree and this is 17, so in this smaller triangle which is ABO, this angle is 17, this is 90 degrees. So remaining angle we can find, because interior angles of a triangle are adding up to 180 degree. So we can say this F is 180 minus 90 minus 17. So we can write working like, for example, angle F will be equal to 180 minus 90 minus 17. So these are all degrees. So we can use calculators. So 180 minus 90 minus 17 will be equal to 73 degrees. So our angle, this angle F will be equal to 73 degrees. This one we have mentioned over here. Now our target is to find this G. One more thing, if we see this triangle ADO carefully, OA is radius and OD is also radius. So these are two radii. So we are having another rule related to radii of a circle. So we can refer again to those rules, and this is the rule which is saying a triangle formed by two radii is isosceles triangle. So isosceles triangle is the triangle which is having these two angles equal to each other. So this is radius, these two angles will be equal to each other. So we can use this rule. So it means this angle, this complete angle A will be equal to this angle. So this one we know is 73. So remaining angle will be how much? We can say that angle, this one, G plus 17, this angle is G plus 17, will be equal to 180 minus 73 and divided by 2. So what we can do, we can calculate remaining angle. Remaining angle will be what? 180 minus okay, so I will write over here so that you can see. 180 minus 73 degrees, this will be the remaining angle. 180 minus 73, 180 minus 73 is 180 minus 73 will be equal to 107. So this angle, these two angles, angle A plus angle D, is adding up to 107. So angle A will be equal to 107 divided by 2. 107 divided by 2. So 107 divided by 2 will be equal to 53.5. So angle A is 53.5 degrees. Now this complete angle is, this angle is 53.5 degrees. So now we can reach to G angle, which is 53.5 minus 17. So we can write angle G is equal to 53.5 minus 17 degrees. And if we calculate 53.5 minus 17 will be equal to 36.5 degrees. So we will write here 36.5 degrees. So it means this angle is 36.5 degrees. So we have used two rules in this diagram. So in exam, if you will see this diagram, or this is, for example, we have supposed that this is the diagram which we are dealing in exam. So we'll think about the two rules. And first rule we have gone through is diameter bisecting this chord, which is AC, will be making an angle of 90 degree. And the second rule which we have gone through is the two radii of circle are making a isosceles triangle. So these are the two rules, and if we want to see those rules again, and these are the two rules. First rule is this one which we have implemented in this question, and the rule is a diameter bisects a chord at right angle. And the second rule which we have applied in this triangle, in this circle, is a triangle formed by two radii is isosceles triangle. Hopefully you understood each and everything, and don't forget to subscribe Maths TV and forward this link to your friends and like the video as well. Thank you very much for watching. Take care. Bye.